another application. So this one's an application of the inflection point. So finding it and then understanding it, kind of relating it to what the application. Alright, so this is sales. So gotta keep in mind everything's in thousands of dollars, right? I've got total sales in thousands of dollars. For the manufacturer of the automatic car starters released is related to the amount of money spent on advertising. Alright, so X represents the amount of money spent on advertising also in thousands of dollars. Alright, so there's the sales equation, and its domain is important, especially when we get to graph it. So I'm going to kind of highlight it there. This will help me get my picture graphically. Find the inflection point, explain what it tells you about the application, graph the sales equation, label it, and give its domain. Label it over the given domain, sorry, which is the 0 to 100. Alright, so first I'm going to find the inflection point. Alright, so we need to find the second derivative. In order to find the second derivative, I need the first derivative. Alright, so the first derivative is negative 0.03x squared plus 3x. That zeroes away. The second derivative, negative 0.06x plus 3. Alright, so this is what I need, the second derivative. Set it equal to 0, and that's a key step, so make sure you show it. Because the inflection points only occur at either where the derivative doesn't exist or is 0, and this derivative always exists, so it's the 0 case. Alright, then solve, and this one's a pretty just solve for x, so I'm going to add the 0.06x to the other side, equals 3, divide by the 0.06. And so the inflection value is at 50. Right, the inflection point would be at 50, s of 50. So in order to find the point of inflection, I have to plug the 50 back in to the original point. So I'm going to go back here and plug 50 into it. And that'll also help me out with my window a little bit, because the inflection point usually occurs sort of halfway between. Alright, so when I plug 50 into my equation, I get 52,700 is my inflection point. Again, right now it's really technically a possible inflection point. So I'm going to go to the graph to see if it is. So now I'm going to graph my original function. Graph that s of x. And I actually popped it up. I've got my graph. I've got it in my graphing calculator here. And so negative 0.01x cubed plus 1.5x. So this is the original, and I put 220 instead of 200. I need to change that. There's be another 0 there, right? It's 200. Let me double check. Negative 0.01x cubed plus 1.5x squared plus 200. Alright. Then I'm going to adjust my window. If you graph a standard window, you won't see this calculator. It starts at 200, right? 200 is the y-intercept, so I know I need to change my window. And so I'm actually going to use the inflection point to help me out. So if I go to window, and I've kind of already adjusted here. If you remember, the domain was from 0 to 100, so I only want the part of the graph from 0 to 100. Now I left it negative 10 from the standard window, because I like to see my axes. And then I went 10 units after my domain. My domain was 0 to 100. So I'm graphing between negative 10 and 110, just so I can see the picture really well. So I didn't scale it, but I might scale this by 10 so I don't have a bunch of dash marks. Alright, then in my y, again, I'm leaving the negative 10 because I like to see my axes. But I went to 6,000. If you remember, the inflection point was at 2,700. I kind of rounded that to 300, and then doubled it. Right, because the inflection point typically is halfway between. And so to see the picture, my guess is that it should be somewhere between 6,000 and 0. And then I scaled it by 500. Scaling just means that's when the dash marks show up. And so instead of having 6,000 dash marks, which you can't see, I'm going to say there's a dash mark every 500. So there's, again, only a few of them. And then hit graph, and it should give you a nice looking function. Right, which again, we're only going to graph from 0 to 100, and I'm actually going to use my calculator to find those 0. Now the 0 is at 200, but you can check. Hit second trace value 0. Right, that's where we'll start, 0 to 100. Then hit second trace value and type in the end point, which is 100, right? That's where my domain ends. And so we end right there at that peak. So when I go to graph it, that's where I'm going to graph my function. I'm going to stop there at 5,200, and then the inflection should be somewhere in the middle, and I'm going to check that. Second trace, the inflection is at 50, and 50 is right there in the middle at 50, 2,700. All right, so there's my graph that I'm going to go put in my notes. All right, so now the graph. So we start here at 0, 200. It kind of has this S shape, moves up. Stopped at 100, 5,200. In the middle was that 50, 2,700. All right, so remember, this was the dollar amount in thousands spent on ads, advertising. This is the sales in thousands. How much they got from sales, thousands of dollars. How much they spent, how much they got, everything's in thousands of dollars. So this 50 would represent $50,000 spent on advertising. This 2,700 is $2,700,000 in sales, so really it's $2,700,000 in sales. All right, which this is the inflection. All right, so kind of interpreting the inflection point, all right, so the inflection, which is that point, is when they spend $50,000 on advertising, I'm going to say ads, the sales return on that money is, again, it's $2,700,000, so it's $2,700,000 in sales, whatever it is they're selling. That's how much they get on their return. So what the inflection point is this is when sales are increasing at the fastest rate. That's what's significant about it. This is the law of diminishing returns. Now, we don't get into it in this class, but if you take an economics class, they talk about the law of diminishing returns. This is when it's happening, meaning even though they're going to spend more money after this point, so over here it's concave down, you'll notice the more money they spend, the less they get back on their return. So it's not worthwhile to spend $60,000, $70,000, $80,000. They're going to sell more, but the return is less. And so after that $50,000, the return on sales the rate is decreasing. Now, they're still selling more, but the amount spent versus the amount more that they're selling is decreasing. Right? So it's not worth their while. The inflection point is sort of where they want to stop. They don't want to spend more than $50,000. And again, sort of hand-waving the law of diminishing returns, but basically the inflection point is your magic point. That's where you want to get to. All right, we'll stop there. We'll pick up the last application in the last. So really, the biggest thing is what you need to know. This is when it's increasing the fastest. Your sales are increasing the fastest. All right, we'll stop there.